Integration by parts. Every differentiation rule has a corresponding integration rule, right? So every differentiation rule rule has a corresponding
equal or opposite
integration rule. So for example, the chain rule has U substitution. What other rules? So there's the product rule, right? So how do we, if we have a product, how do we undo that, right? How do we get the integral? So the product rule. So let's think about what does the product rule say? So the product rule says d by dx, if you're taking the derivative of a product, f of x, g of x, that is equal to the first function times g prime of x plus the second function g of x times the integral, the derivative of the first function. So what if we take the integral of both sides, right? Or take the antiderivative of both sides. So the antiderivative of this is just going to be f of x, g of x. And this is going to be the integral of f of x, g prime of x, dx. So the integral of f of x, g prime of x, dx, plus the integral of g of x, f prime of x, dx. And what we can do is we can rearrange that so that we are solving for this. So the integral of f of x, g prime of x, dx, so this, is going to be equal to, so just take this over here, so it's going to be f of x, g of x, minus the integral of g of x, f prime of x, dx. Oh, as far down as it goes. And another way to say that in a little bit shorter notation is that the integral of f g prime is equal to f g minus g f prime. Or in differential notation, it looks like this, where we use u and v. So we say u dv, the integral of u dv is equal to uv minus the integral of v du. So on your formula sheet, I think you get two of these guys. Right. And you get this one here. And what form is the other one in?
Form of f g prime is equal to f g minus g f prime.
So that f g prime, this one, okay. Okay, and when you see this, you can just put at x, right? F of x, g prime of x dx is equal to fg minus g. So basically what this says is, if we're looking at the integral of something and it's a function times another function, if we can treat one of those as a function and the other one as the derivative of some function, okay? So easiest way to do this with an example. So let's say we want to do the integral of x cos x dx. All right, so, and what we're looking for is this in this form? So integral f of x g prime of x, which would be equal to f of x g of x minus the integral of g of x f prime of x. And we need some dx's, dx. So can we write it in this form? Does it look like a function, so f of x and g of x? So we could say, well, if x is equal to f of x, then cos x would be g prime of x. And then, okay, f of x I've got. If I have g prime of x, can I find its antiderivative? Okay, and if I can, then I use that here, and then f prime of x, if I have f of x, can I find its derivative? Right. So the question is, do we make f of x equal to x? So we look at this and say, okay, this is in this form. Either this is f of x, then this is g prime of x, or vice versa. So here's what we're going to ask. Do we make f of x equal to x and g prime of x equal to cos x, or vice versa? Okay, so you have a choice. Here's how you make that choice. We want to assign f of x such that its derivative is easy to find. Okay, so we have a choice. So we want to assign f of x such that its derivative is easy to find. And assign g prime of x such that its antiderivative isn't hard to find. Exactly, yeah, there's a distinction, right? Maybe it's not easy, but we want it to be so it's not hard. Yeah, it's not that difficult, right? All right. So if we make x, if we make f of x equal to x, the derivative of that's easy to find, right? It's just 1. If we make g prime of x equal to cos x, its antiderivative is easy to find, right? Or it's not hard, right? It's just sine x.
Come on.
Okay, so here's what we're going to do, right? Here's the solution. So here's what we start with. We got x cos x dx. And we're going to say this, right? We're going to say, all right, I'm going to let f of x equal x, which means that f prime of x is equal to 1. I'm going to let g prime of x equal cos x. So what's g of x? Sine x, right? Okay, because that antiderivative wasn't hard to find. If we're doing it in this form, u dv is equal to uv minus v du, then we kind of do the same thing, right? Only in terms of u and v. So we say u is equal to x, and du is equal to dx, right? Just take the derivative. And we say v is equal to, v dv is cos x dx, and v is equal to sine x. Okay, so we've assigned u, the function, to be this. We take its derivative, so du is just dx, and dv, so we've said dv is going to be this, cos x dx, and then its antiderivative, v, is just equal to sine x. And now we just plug in, right? So either form of the formula. If I'm using this form of the formula, I'm plugging these guys in. If I'm using this form, then I'm plugging those guys in.
Is there going to be one we see almost exclusively, or do we use both?
Just be able to use both. So I'm going to use the UDV one, okay? But you should be able to use both of them. So if I'm going to use the UDV one, then this is what we've got here, and we're going to substitute in, right? So we say that the integral of x cos x dx, so this is u and this is dv, is equal to uv, so x times sine x. So this is u and this is v, and it's like, could you have left some room? Okay, you don't have to write this stuff down. I'm just writing it down so that we can see how it's paralleling what's up here. Minus the integral of v, so that's sine x dx. Okay, so du is dx, right? So this is v, and this is du. All right, so we've chosen a u and a v. We've got u, we've got du, we've chosen, sorry, dv, and then we get v, and then we can fill this in, right? So u, dv, we chose our u, we chose our dv, is uv, so we've listed that up here, minus the integral of v du, and then we just do it. So this is equal to x sine x, and what's the integral of sine x? Okay, negative cos x, so this is going to be minus negative cos x or plus cos x. And it's a general, so what goes on the end? Plus c. Okay, so the integral of x cos x dx is x sine x plus cos x plus c. Okay, and you can check that out by taking its derivative. Exactly. Okay, so kind of here's the formula. What you want to do really is write down the formula, figure out what's u, what's v, what's u, what's dv. Once I've got that, what's du, what's v, right? So this has an easy to do derivative, and this has a not hard to do antiderivative. Right? That we can do its antiderivative. Which brings us to this one from a long time ago, which we had put on that sheet, right? But we never actually did this one. Sort of, this is left as an exercise for the reader.
I did.
Did he? Good. So here's the trick to doing this one, right? Because you're saying, well, you just have one thing there, right? You just have ln x. Where's this u dv? You just have ln x. So here's what we write. We write this as ln x times 1 dx. Okay, that's the trick. So we write it as a product. And we say, all right, well, what's u? So u is going to be ln x. And what's du? Well, du is 1 over x dx, right? So u is something whose derivative is easy to find. And dv is 1 dx. And what's the antiderivative? Just x, right? So we've written it, we had to do a little trick, right? Write it as a product, okay? When it wasn't a product, it was just ln x, but we threw in a 1. So we wrote it as a product, and then we're going to use integration by parts to do this. Okay, so what do we say? Let's go just up here, let's finish it on this line. So it's u times v, ln x times x, or x ln x, minus the integral of v du, so that's x times, so du is 1 over x dx. Okay, so again, just using the formula, right? The integral of u v prime, or sorry, u dv is equal to uv minus the integral of v du. Okay, which is equal to, so let's just separate this out. That probably could have gone up there somewhere. So we've got x ln x. What's x? This is just 1, right? So minus the integral of 1 dx, which is just x, so minus x plus c. So x ln x minus x. You do that, and you'll get ln x. Okay? So that might have been one that, you might not have figured out on your own. This is sort of the trick to doing it. Okay, so it uses integration by parts, splitting it up as a product. So that's what we're looking at. I've got something written as a product. I want one of those to be a function and the other one to be the derivative of some function. T squared minus, times e to the t dt. Okay, so we got to figure out a u. Let's do this off to the side here. So u. So what's u going to be? Something that's derivative is easy to find.
T squared.
T squared. Yeah, I mean, both of the derivatives are easy to find, right? But the antiderivative of e to the t is easier to find. It's just e to the t. So u is equal to t squared, and du is 2t dt. And dv is e to the t dt. So v is just e to the t, right? And a derivative of. Okay, so just keeping in mind the formula, we plug in. So the integral of t squared e to the t dt.
You also need a 1 over 2 equal to. Oh yeah, you're right. My bad.
Okay, so we've got
Perfect.
uv prime. It's going to be uv, so t squared e to the t minus the integral of v du, so e to the t, and du is 2t dt. At which point you say, well, that's hardly like really easy. Okay, so we've got this t squared e to the t, but what's this? It's like what we have up there, right? It's like a product. So we're just going to do this again,
Oh,
right? Integration by parts here. We have a product. Right? So this time, we'll start with u is equal to t. So now we're doing this guy, right? Maybe I should write this here. So we're doing the integral of e to the t times 2t dt. So we'll say u is equal to t. Du is just dt. dv is e to the t dt. And so v is equal to e to the t, right? Like we're back here again.
yeah.
Okay, and what's this equal to? So the integral of e to the t times 2t dt is equal to, so we go uv again, this time t e to the t. So t times e to the t minus the integral of, okay, now this time it's just v du, so it's just e to the t dt, right? That's doable. So that's equal to t times e to the t minus, and what's the antiderivative of e to the t dt?
ET.
E to the t, so minus e to the t plus c. Okay, so this replaces this, right? That's that. So we've done two integration by parts. The first time we did it, it led to, I still have a product here, right? So how do I find its integral?
Where's it?
Where did the 2 go? Where did the 2 go? 2 is just a constant, so we can just actually kick it out front. So let's do this, right? Here, let's do this. T squared e to the t minus 2 e to the t dt. Sorry, should have done that first. So we just take the 2 out here, then we just worry about this. So.
That's what I was.
Damn. How did that move? Oh, nuts. That won't move back. 2e to the t dt. Okay, well, that's a mess now. Okay, let's rewrite that. Sorry, yeah, should just move the 2 out front as the thing, and then we'll just do the integral of e to the t times t dt. And what do we say? U is equal to t, du is dt, dv is e to the t dt, and v is e to the t. Okay, there. Yeah, and take out that 2. T dt. Okay, so this is going to be replaced by this. So we've got t squared e to the t minus 2 times this. So t e to the t minus e to the t. And some general constant, right? Now, maybe that's a different constant than it was before, but we'll just write it as some general constant. And then we'll expand this. So t squared e to the t minus 2 times t e to the t plus 2e to the t plus c. And that's it. Okay, let's carry this down. So the integral of t squared e to the t. Yeah.
It would differ based on what.
It's a different constant. Okay, but
Well, I guess you could.
I'm just going back to plus c. It's plus some arbitrary constant, and if you want to double that now, go ahead.
But you need to write 2c, otherwise it would be wrong.
Yeah, well, I could write c1 and c2.
Exactly, and then like let c2 equal double c1, you know?
Yeah.
We don't want people thinking it's some different constant.
Yeah. Okay, so there you go. More. 2 more, 3 more, 2 or 3 more. So the integral of e to the x cos x dx. And same thing's going to happen this time as happened last time. But, okay, something whose derivative is easy to find, so u is equal to e to the x. Du is e to the x dx. Dv will be cos x dx. Okay, so this is u, this is dv. So v is sine x, right? What's the antiderivative of cos x? It's sine x. And then dv is cos x dx, right? You can just check that if you're doing the, you want something whose antiderivative isn't hard to find. Okay, let's just put the formula down. So u dv is equal to uv minus the integral of v du. So I like to write out, right? What's my u, what's my du, what's my v, what's my dv? Now we can substitute in. So the integral of e to the x cos x dx is equal to uv, so e to the x times sine x, minus the integral of v, which is sine x, du. Okay, wait, let's just write that as e to the x sine x dx. And you say, wait a sec, I mean, you were trying to do the antiderivative of e to the x cos x dx, and now you got an e to the x sine x dx antiderivative. So, you know, how does this make things simpler? So we say, well, what we did for this, we're going to do for this. Oops. So we're going to go off to the side here, and we're going to find the integral of e to the x sine x dx. And it's like we're going around in circles, right? It's like, well, you know, is this really going to lead to some conclusion? All right, so we're going to say the exact same things we said, right? U is e to the x, du is e to the x dx, only this time dv is sine x dx. So what's v? Negative cos x. All right, so what's this integral? Integral of e to the x sine x dx is equal to, so we got the formula over there, so u dv, e to the x times sine x e to the x.
Minus cos x.
Sorry, yeah, uv, so minus e to the x cos x. minus, and we've got v, so minus, and we've got v, so it's going to be a plus the integral of v negative cos x. Or sorry, where is it? V du. So v, so e to the x cos x. E to the x cos x.
Nice.
Nice, right. Because what happens? Well, what do we got here? We're going to substitute this in. So I've got the integral of e to the x cos x dx is equal to e to the x sine x minus, and then let's bring this in, negative e to the x cos x plus the integral of e to the x cos x.
What's the?
Right, and then a plus c. But wait a sec, we've got this here, and we've got this here. Right? So we've got the same thing. Okay, so let's just work with this a little bit. We'll just expand this out, so take the negative through this. So we get e to the x cos x dx. Okay, so we got e to the x sine x minus negative, so that's going to be plus e to the x cos x, put the x in the right spot, minus the integral of e to the x cos x. Okay, let's bring that to the left side, right? Because they're the same term. We've got the integral of e to the x cos x dx. So we add that to both sides. So we're going to get two of these guys, right? This comes over here. We get two of them. Is e to the x sine x plus e to the x cos x divided by 2. So the integral of e to the x cos x dx is equal to, so a half, let's factor out the e to the x, and we get sine x, don't forget the c, plus cos x plus c, some different c than is above, but it's just some arbitrary c.
Is there an issue that comes up from the integral being on the right side that doesn't have a dx, adding to one that does have a dx?
Yeah, I forgot the dx. My bad, that's all. Again, so two applications of integration by parts, right? Which surprisingly then led to this. Hey, when I did this guy, I just ended up with what I started with originally. So now we have two of them, but this part simplified, and there's our answer. Okay, one more. Then you can work on this and suffer the pain. Definite integration. So what if we're doing the definite integral? So what would that look like? So if we're doing the integral of a to b, f of x g prime of x dx, okay? So we're just going back to that notation, okay? Which will be equal to the product f of x g of x evaluated from a to b minus the definite integral from a to b of f prime of x gx dx. Okay, so let's do one. Integral from 1 to 3 of x cubed ln x dx. So, first thing we want to do is figure out what's u, what's v. Well, we already know what the antiderivative of ln x is. We don't want to do that. Right? So then we're going to make u equal to ln x. And du will be 1 over x dx. And dv then is going to be x cubed dx. So what's v? Well, yeah, that antiderivative is not hard to find, right? 1/4 x to the 4th. Okay, here, let's box this up, and then we'll just go up here and put in, so that's equal to uv, so that's going to be x to the 4th ln x over 4, evaluated from 1 to 3. Okay, so that's this guy. Only I used u's and v's, but minus definite integral from 1 to 3 of 1/4 x to the 4th times 1 over x dx. Okay. No constants here, right? We don't need them. They would just add in and subtract off. So this is equal to, so let's just keep this for now, x to the 4th ln x over 4. And let's simplify this. Well, we do a little simplifying here. What's this going to simplify to?
X cubed over 4 dx.
Yeah. Okay, so what's its antiderivative? So we've got to kick the power up to 4, divide by a quarter, so it's going to be x to the 4th over 16, evaluated from 1 to 3. Okay, and now all we do is plug in. So we start with the 3. 3 to the 4th ln 3 over 4 minus 1 to the 4th ln 1 over 4 minus, okay, and now this guy, and we're going to be subtracting the result of that, so 3 to the 4th over 16 minus 1 to the 4th over 16. What can we just sort of simplify by sight right now? How about ln 1? What's ln 1? Ln 1 is 0, right? So this term here is just going to be a 0. Okay, so we have 81 over 4 ln 3, 81 fourths ln 3 minus, okay, what's 3 to the 4th? This will be, well, let's do this. So minus 81 over 16 plus 1 over 16. What's negative 81 plus 1? Negative 80 divided by 16 is 5. And we'll leave it like that. Suppose you could kick the 81 fourths up into the power with 283 over 4. That's it.
How did you move the 3 up? Not 3.
Oh. Bad
You
writing.
changed the other one to 2 now.
Now it's lower 2.
Yeah, the one you just did.
Come on!
Lower 2.
You know that homework.
I raised.
God damn it, why is Peter so right? He's never been right before, damn it.
Okay, and no plus c, right? Because this is actually a number, right? Definite integral evaluate to a number.
Plus c, but c is 0.
Yeah, well, because you added it and subtracted it.